So we're going to go to page 36, the worksheet that you were supposed to do, but we chose to do Delta Math. But I still want to make sure you know how to do it when it's on paper. So we're going to look at that just together. You don't have to do it on your own. We're going to talk through. Can you sit out there? Just sit up there. All right, so we're just going to talk through the left-hand side, just to make sure. And then there's one of these that I'm going to have you star, because there's one like it on the test, and Delta Math didn't hit it. Delta Math's great. Just sometimes I can't find some stuff in there. All right, so the first thing, we need to know the difference between these three kinds of arcs. So minor arcs, let's just go ahead and write it on here to help out some classes. All right, they measure less than 180. They take up less than half the circle, and we always name them with 2 letters. So I'm not going to list all of them. That's what I kind of don't like about the worksheet. I don't need to list all of them to know what one is. So we'll just say RS right here is a minor arc. RQ is a minor arc. RU is a minor arc. We always name them with 2 letters. Major arcs go past half of the circle. We have to name them with 3 letters, so that if I wanted you to go from R to S but take the long route, with just 2 letters, it's the short route, and it's a minor arc. If I want you to take the long route, I list where I want you to start and where I want you to end, and then I can list any point along the way. I'm going to choose Q, it doesn't really matter. So those are our majors. And our semicircles are exactly half the circle. They're cut off by a diameter. So on this guy up here, and this is just a review of yesterday's before we do today's. If I grab a diameter, a semicircle would be that one. There's a bunch of them. It's just half of the pizza. You can name them with 2 letters or 3 letters. So I'm just going to say RQT is a semicircle. Done. And then yesterday, we also, on Delta Math, dealt with some where you were given some angles. I want you guys right now just to do these 4 on the left. If they go well, we won't do those other ones. So I'm going to pause the video here just for a titch while you guys, see if I can find my pause button. There it is. I'm just going to pause. So we're just going to check these 4 on the left together. All right, so this means we've got a minor arc. We'll use 2 letters. We're going to go from G to J. And we said that their measures are done in degrees. Today we're going to be finding how long that is. So today's going to be a little different. But yesterday we just said that it's equal to the same measure as the central arc that's cutting it off. How many of you had a 90 for that? I didn't walk around, but oh, thanks, awesome. All right, and now I'm supposed to do a major. I'm supposed to go from G to J all the way around to I. So I'm supposed to head this way. So again, I just need to do 150 plus the 90. That's the angle that's been cutting it off. What is that? 100 and, what's 90 plus 0? 250? Am I right? I'm terrible with arithmetic. 241? All right. 241. Did you have that one right, Tess? Good. All right, H to G to J. Let's go back up here and erase my other stuff. That's also 3 letters. It actually ends up not being a major arc. It's a semicircle because a diameter cut it off. And last one up, H to J to I, which is all the way around here. What did that end up being? You'd have had to do 360 minus 90 minus 90 minus 151. Did anyone do that? What'd you get for it? Go ahead and tell me. It's the whole way around minus 90, so minus 180.
331.
331?
Yeah.
All right, I'll take it. All right, so hopefully those went well. I was going to walk around and check, but I felt good about it yesterday. And then we need to know how to, these 2 things we need to know how to do today. So to find the circumference, our formula is 2 pi r. When it says to leave in terms of pi, you just go 2 times pi times your radius, and then just don't do the pi part on your calculator. Now today there's going to be a lot more to do, but it's still, if it says in terms of pi, you're just going to enter everything on your calculator and leave the pi off and put the pi down and just write down what your calculator says next to it. We're not going to do 19. It's got lots and lots of words, but this is the one I want you to star. I couldn't find any in Delta Math like this. And you're tested on one similar. So just to make sure, I'm going to slow down a little bit on number 20, and then we'll go take about 10 minutes of notes, and we'll have a nice short day today. Did I remember to press record again? I'm just going to check. I did. Sweet. All right. So we've got a bike wheel. Go ahead and draw it. That has a diameter, so all the way across, of 20 inches. That'd be kind of like one of those little dirt bikes. Another bike has a diameter of 26 inches. That's actually a standard bike wheel. I'm going to put 26 on here. And then it says to the nearest inch, so we'll be rounding and using our calculator, so take that out. How much farther does this one go than this one? When you do one revolution, you travel the circumference of the bike wheel. Does that make sense? So we need to find the circumference of this guy and the circumference of this guy. And then all we need to do is subtract them. So for the bigger wheel, it's going to be 2 times pi times the radius. So can you go do that on your calculator for me, Bjorn? And it says to the nearest inch. So we'll take this to the nearest 10th. And then, so 2 times pi times 13.
81.
Let's go 81.7. Just to make sure we are accurate to the nearest inch. So that's how far that they travel in one revolution. If you were to divide that by 12, you get how many feet they travel, like with one turn of that tire. This one over here will be 2 times pi times the radius is 10. So on your calculator, you can either just do 20 times pi or 2 times pi times 10. I don't really care, but my calculator person says 62.8 inches. So the question was, how much farther does this one travel than this one? So if you could subtract those for me, Bjorn. What do you get? 81.7?
18.9.
18.9, and this said to the nearest inch, so 19 inches, or about 1 foot and 7 inches farther. All right? That's it for yesterday. So you feel like that you got enough notes in Delta to be okay with that? When I shorten stuff, I just want to make sure I don't shorten it too much. So then we're going to hop in our notes, which I think I have to go backwards for. All right. All right, so 10-6 we're on. They have shades up on here. We're going to be doing, I'll tell you what part we're going to hop on, because we did a majority of it yesterday. I'm going to get rid of these slide down things. We did all this yesterday. I just shortened it up for you, so we don't need to do that page. We did all that. Yep, we got through all of that in 10-6. I'm just trying to figure out where I need to pick up the notes. I think we did the majority of it, guys. Here we are, just at the bottom of the page where it says Theorem 1010. We actually did more than we needed to yesterday, so this is going to go really fast. What page is this on, Carly? 19. Page 19. So we're going to hop on page 19 in your notes today. And what we're going to work with is the length of the arc. So I want you to bold that a little bit right there. Yesterday we dealt with the measure, and we said that its measure is the same as the angle that cuts it off. So if that was 70 degrees, the arc was a 70-degree measure, but that's not what its length is. All right? So to get its length, you kind of have to picture like if this was a pizza, and if I did go cut out a wedge that maybe I went in and went out, and I cut out a 60-degree wedge of it, I'm cutting out a fraction of the whole thing, correct, Bjorn? And it's a fraction would be 60 over 3/60. So go ahead and write this down. That's the fraction that I cut out. The whole thing, or all the way around here, is 2 pi r. But I'm only cutting out a piece. And my piece is 60 out of 360. So if this had a radius of 10 inches, So as a 20-inch pizza, when you order a pizza, you order by the diameter. They'll say a large is 20 inches. What they mean is the diameter is 20 inches. So I would go up here and I'd say, well, this would just be 60 over 360, this piece of the circumference. So go ahead and put that there. What you do here depends on whether you're told to round or be in terms of pi. Okay, I'm going to say in terms of pi. So I'm going to put a pi down. And then this is where you have to make sure you're using whatever calculator you're going to use the whole time. All right? You're going to do 60 divided by 360. Or if you want to reduce it before, you could. But if you do it wrong, then it kind of sucks. So I would just leave it. I would just go 60 divided by 360 times 2 times 10. Hit enter. If it's not a whole number, we need the fraction. So if you're on the graphing calculator, you hit the math button, and then you hit enter twice, and it'll change it to its fraction. And I'm seeing 20 over 6, 10 thirds. Is it reducing to 10 thirds, graphing calculator people? So we would say 10 pi over 3. If you're allowed to round, then you just enter the pi in and you round it. Those of you using the TI-30, you have a fraction reducing button. If you don't know where it is, raise your hand during the homework. All right, so we're just going to go to the next page here. And we're going to be working with finding arc length. And there's a formula for it. And we're going to write it down because we just sort of came up with it. The length of the arc, go ahead and write it nice and big over here. You take the degrees you cut out. On this one, it's going to be 90 degrees. On this one, I'm going to have to figure it out, okay? And you divide it by 360, so you know what fraction you're cutting out. And then you multiply it by the circumference. So you just go 2 times pi times r. So it's very formulaic today, and it's an easy one as long as you know how to work your calculator. So on this guy over here, it wants you to find the length of arc xy. It's going to equal, it's a fourth of the pizza, you can see it, but we'll write 90 over 360, but honestly, when I look at that, I go, oh, it's a fourth of it, right? All the way around the pizza is 2 times pi times the radius. So be careful. What's the radius on this one, Julia? 8. Yep. And it says in terms of pi, so practice on your calculator. You're going to go 90 divided by 360 times 2, skip over the pi, times 8, math, enter, enter. Or if you're on the TI-30, you have to figure out how yours reduces those fractions if you don't want to have to do it in your head. So 90 divided by 360, math, enter, enter. Actually, this one comes out to be a nice 4. Am I right? And you might say, how do I know that? I know this is a fourth, and 2 times 8 is 16. So it would have been really easier to stay off my calculator. This would be the distance from here to here, the length of the arc. All right? On letter B, we've got a little work we need to do because we're trying to find arc XY's measure, or length, sorry. It's some degree over 360 times 2 times pi times 15. But they didn't quite give me that one. They gave me the rest of it. So what do you think I'm going to do, Eve? If this is 240, how am I going to figure out this piece of it? Yeah, so we'll just go 360 minus the 240. I must have been cutting out a 120 degree wedge. Maybe you see that that's a third, right? If you see that that's a third, you can put a third right here. And maybe you can say, well, 15 divided by 3 is 5, and maybe you can just get the 10 pi. Otherwise, it's up to you how much you want to be dependent on your calculator. All right, and that would be labeled centimeters because it's the length of it. So down here, I'm not going to have you worry about this. This is just a bunch of words that's not going to help you with anything. So we're going to cross that off. We're going to go down, and I'm not going to deal with these either. I'm going to have you do one on your own down here. So draw a little bar. Do you have a little room down there? I'm going to have you draw a circle. I'm going to go like this. I'm going to make this, let's make it a 28-degree wedge. I'm going to put a 7 on the radius, and I'm going to ask you for the length of that arc. Let's go to the nearest 10th on this one. I'm out of calculators, so I'm going to have to hope that viewer does it right. All right, let's go to the nearest 10th, so you don't need to worry about the math, enter stuff, and you're going to put the pi right in there, right after your calc. Don't use 3.14, use your pi button. I'll give you a minute to crank that one out. Actually, use the other calculator just to make sure. I like it. Let's go to the nearest 10th. Perfect. It's right. I think we've done. Someone's given a ton of notes. Yours is set up right. You'll have it right when you're done. Yep, there it is. Good. Yeah, this side of the room's all correct. So, there we go. You have it, bud? Go do it. You'll have it right. Yours is set up right. Sweet. I think we can be done. I'm going to just check one more row here. Where's yours down here? And then there's your answer. Perfect. Perfect. Go do it. Oh, do you have your crumble? Use decimals. I'm out of calculators. I said to round to the nearest 10th. So go ahead and enter the pi actually on your calculator. All right, they look good, guys. So really big, let's write our formula down. I just saw a couple people who had it off. So for those, like 2, it's x degrees over 360 times 2 times the pi times the radius. And you can actually just go and enter it right on your calculator. So you're going to do 28 divided by 360 times 2 times, hit your pi button, times 7 equals. And then, what was it, 3.4 I think is what I saw? Yeah, so 3.4. Perfect. Let's go and try our delta and see how it goes. There's 2 sections. It should say delta 10.6b. If you're not seeing it, let me know. You're my first hour. Sometimes I don't have it